Hi everyone, let's look at the Leet code problem. Add two numbers. You are given two non-empty linked lists representing two non-negative integers. The digits are stored in reverse order and each of their nodes contains a single digit. So basically this is number 342, which is represented in the reverse order. The request is to add these two numbers and return this in another linked list. Now let's see how to solve this problem. Now let's look at this example. So we have one linked list L1 which is having values 2, 4 and 3. As mentioned earlier, this is represented in the reverse order. So this is actually 342. Second linked list is L2. In the same way, it's also shown in the reverse order. We will have to maintain another variable called carry because you could have a carry for a addition. So we'll start here and we'll move forward. First we'll sum this and then what we'll do is we will store the modulo 10 of this sum into L3. So let's assume that sum is 7 and then if I take modulo of 10, that will give me the remainder. So that is 7 in this case, and I will take 7 by 10 and store it in which is 0 and store it in this carry bit. Let's move to the next one. So the carry bit is 0 here also. So initially it was 0, now it's 0 again because there was no carry here. Sum this 0 plus 4 plus 6. So that will become same concept. We'll take 10 modulo 10 and store it here. So this will become 0. And then we'll take 10 by 10. And so that will move to as a carry here. Then again we'll sum this up. And this will become same concept. You will again do the modulo and store it here, and if there is a carry, then we would have brought it here. Now let's take another case. So assume this was maybe like 8. Then what would have happened here is this would have been 1 plus 3 plus 8, that is 12. So 12 mod 10 would have given us 2. So this would have been 2, and then we would have had a carry bit 1 which would be sitting here. Now this means that there is one more data point available. So if there is carry left over, then what we'll do is we will insert that as the next node, and this will be our final linked list. I hope this is clear. Now let's just code this up. To start with, we will create a dummy node. This makes the code a little bit more easy to read. So I'll just keep it there. And then we'll make list node star L3 equal to dummy. We will iterate through both linked lists as long as both doesn't reach the end. We also need to keep track of a carry variable. Then we will calculate the sum. This will be L1 of val plus L2 of val. Then we will create L3 of next is equal to new list node with sum modulo 10. So only the remainder will get stored in this corresponding node. We will set carry is equal to, so here we'll also need to add carry. Sorry, I missed that part. So then we'll also need to update carry to sum by 10. Then next step is all these nodes need to move to the next node. So L3 will be equal to L3 of next. L1 will be equal to L1 of next, and L2 equal to L2 of next. Now the next thing is, assume that one of the linked lists was longer. So we have to take care of that case. So we have to handle the remaining nodes of L1. While L1, what we will do is, we will do the same logic here. Only thing is we will not have the L2 value. We will just add this L1 plus carry, and we will do the same thing as shown before. We'll just set the L3 of next this way with the sum, and we'll also update the carry accordingly. Yeah, I'm just copying for ease, but yeah, I hope the conditions are clear. So L2 will not be there, everything else will be there, and this is what we'll end up with. Then same applies for the other linked list where L2 is longer. So this will be all L2. And then finally, after parsing through all the lists, I could still have a carry. So if there is carry, Then what we'll do is we will just bring in the carry along. So this will be carry. We can just make this as L3 is equal to dummy of next, and then we can just delete dummy, and then finally return L3. Time complexity will be order of n, where n is the length of the longer linked list. Okay, and space complexity will be order of 1, because the return is an expected data structure. So that is an expected one, so we'll just keep it as order of 1. Now let's just run this. Looks good. Yep, so this also looks good. Hope this is clear. Have a good one. Thank you.